Identify the structure of the starting material for the following reaction. So if we look at what we are given here, we see that our reaction conditions are aqueous, acid, and heat. So these are conditions for an acidic hydrolysis reaction. And if we examine what the product is, we see that we have at one side a carboxylic acid, and we see at the other side of this molecule that we have an alcohol. And so any carboxylic acid derivative can be hydrolyzed to yield a carboxylic acid. And if we look at our options, these are all esters. So if we want to just draw a general formula of an ester. So here is just a generic ester saying we've got a carbon group on one side of the carbonyl and an oxygen with another bond to carbon on the other side of the carbonyl. And whenever we hydrolyze an ester, so acidic hydrolysis would be one way of doing this. So aqueous acid and heat. Whenever we do that, what happens is you cleave this bond between the carbonyl carbon and the alkoxy group. And so what you're going to form when you do that is your carbonyl carbon ends up being your carboxylic acid. And this portion of the molecule, so let's just kind of highlight it in or underline it with another color, that's going to end up being the alcohol portion. So you will also end up with an alcohol. Okay. So we know that the oxygen and that carbon group in the alcohol are coming from that alkoxy group, and we know that the carbonyl portion of the molecule is what's going to form the carboxylic acid. And so the OH from the carboxylic acid, that's coming from water. So that's the new water that you're adding when you do this hydrolysis reaction. So with this information, we can backtrack and see what's what. So this alcohol is that OR part of your ester. This carboxylic acid would be from the carbonyl. So we know then that in our starting material, we must have had a bond between those two atoms. Okay, so we should have had a bond between these atoms in the starting material. Right? And seeing that the alcohol and the carboxylic acid are part of the same molecule, that tells us that we had a cyclic ester, because once we cleaved that bond, if these two R groups were still attached together, then we would still have them attached together in the product. Okay, so what we're going to do to work this backwards then is to recognize that this oxygen was attached to that carbonyl of the ester, and so we just need to count to see what size ring we're making. So the oxygen is going to be inside the ring, so I am going to count that. 3, 4, 5, 6. So this tells us that we had a 6-membered ring ester. So we can draw a 6-member ring ester. And so we can put those numbers back on here. So 1, 2, 3, 4, 5, 6. So those are the 6 members of the ring. And then we should also note that there was a methyl group on the atom that we have labeled 2. So we want to make sure that there is still a methyl group on that atom in the product. And there it is. And so this matches our option C.